Hi.
Hi, am I audible?
Yeah, you're audible.
Okay, so in the previous session, we had our introductory session
Yeah,
in data structures and algorithms. In that, we have basically discussed about what is data structure. So it is the way of organizing, storing, and managing the data in a computer system. What are algorithms? Algorithms are the way of way of some procedure or something which is like operating on the data. So algorithms
yeah.
will take some input and produce some output.
Okay.
Then we discussed what are the types of data structures where we have linear data structure and non-linear data structure. In that we have got primitive and non-primitive, where primitive means they will store a single value, non-primitive means they will store multiple value like a linear manner, then non-linear data structure. Then we have discussed about analysis of algorithm, how we can analyze an algorithm. So time complexity is the first thing. And in that we have our long discussion that
Yeah,
how exactly the thing is done.
yeah,
And then we have discussed about we analyze the time complexity in three different cases, that is best case, worst case, and average case. In interview, we must focus on the worst case time complexity. And these are the
yeah,
like common time complexities example.
yeah,
And there are the three notations which are called basically asymptotic notations. And this is what we discussed in the previous session. Now we are going to move forward our discussion in the same thing.
yeah,
Now we have discussed a lot about time complexity. If somebody is asking us a question regarding same thing, what exactly is time complexity? How will you define the time complexity? So finally, we can say that time complexity is the rate of change of time taken by an algorithm when the input size is changing. When the input size is changing. Now, why we are not analyzing the complexity with respect to the exact time that this algorithm is taking 2 seconds and it is taking 3 seconds. So this one is
yeah,
good because we took the example that generally we analyze the things in terms of the function, how their function is working. So there were two chefs or cook. We took this example.
yeah,
In starting 10-20 hours, the chef one is performing very well. But
yeah,
when 100 hour came, chef 2 is doing very much fine. So
yeah,
now any algorithm is not analyzed on the basis of exact time taken. It is analyzed on the basis of rate of time taken. That is the rate. How this rate is calculated? So we just draw a graph for the same thing. Now let's say this is a graph that we are taking. In one side of the graph, we write input. Or let's just take like a graph. In one side, we take the input. And in one side, we take the time. Now
yeah,
just take an example that when the input was 10, when the input was 10, we analyzed the algorithm. And when the input became 20, then we analyzed the algorithm. On 30 we analyzed, and on 40 we analyzed the algorithm. So
Yeah.
these were the different number of inputs. So here 10, 20, 30, and 40. Now the time is written in seconds. Let's say 1 second, then 2 second, then 3 second, then 4 second. Something like this. 5 second. Something like this time is written. Now let's say this time is 1, 2, 3, 4, 5, 6, 7, 8. This time is 8, 7, 6, 5, 4, 3, 2, 1. Like this.
Got it.
Now let's say when you gave the 10 as the input, you noticed that algorithm is taking 2 seconds. When you gave 20 input, you saw that algorithm is now taking 4 seconds. When you gave 30, you saw that it is taking 6 seconds now. And on 40 input, it is taking the 8 seconds. So now you can never decide now that it is
Yeah.
will take 2 seconds or 3 seconds. So we can decide their rate. So this straight line I will draw here. And this straight line is only the rate of that algorithm.
Yeah.
This straight line is the rate of that algorithm at which the input is changing. So, or basically we should start it from the 0 point only, like this, and all these points should fall like this. So whatever angle is created here by this graph, this angle theta, whatever this angle is created, this is only the rate of change of time. And we analyze our algorithm on the basis of this only. Then we have discussed about that there are three asymptotic notations. So what are these asymptotic notations and how we calculate that exactly? So calculating the time complexity of a simple code. So here we are going to take some example of the code and we are going to analyze the time complexity of that particular code. As we are going to deal with Java, so I am going to write the code of Java. So here public class main, then the main method I will write public static void main string args. And here I will write one line. So int num equals to, or let's say int a equals to 30. 30. Int b equals to 40. Int sum equals to a plus b. And then system dot out dot println sum. Here we are printing the value of sum. Now somebody is asking that tell me what is the time complexity of this code. So when we are calculating the time complexity of any code, we have to remember 3 points. We have to remember 3 points. There are 3 points that we should remember while calculating the time complexity. What is the first point? We will always ignore constant values. We have to ignore the constant values. First thing, ignore comparatively small values. Whatever the small values, we will ignore them. Constant value, we
Mm.
have to ignore them. Comparatively small values, we have to ignore them. And the third,
Sorry, small values in the sense the values we are passing, right?
I'm coming. Let me write the 3 points. I
Okay.
will explain all the three.
Yeah.
So whatever we have the constant values, we have to ignore them. We have to ignore the comparatively small values or the small functions. So ignore comparatively small functions. Now, let's say you are going to market and you thought in your mind that today I will purchase iPhone and I will purchase 1 kg apple or 1 kg banana or whatever. Now in the market, you met one of your friend and your friend is asking, why did you came to market? So as a human nature, I will say I came to purchase iPhone. I will not say that
Yeah.
I came to purchase 1 kg banana. Because in front of iPhone, this 1 kg banana is a comparatively very small value. Now, again, I will give one example for it. Now, let's say there is a function. Function is n cube plus n square plus n, or let's say plus 3n plus 1. Now, let's say if the value of n is 1. So the total equation will be 1 plus 1 plus 3 plus 1. Answer is going to be 6.
Yeah.
Okay. But let's say there are 4 different functions working here. One is n cube is working here. One n square is working. One 3n is working. And one single one is working. Let's say the value of n is 10. The value of n is 10. So here n cube will become 1000. 1000 plus n square will become 100 plus this will become 30 plus 1. Now tell me one thing. What is the value of 1 in front of this 1000? Very less. Even if you include this, it will become 1001. So why we are even including it? So we will always ignore the constant values. We are not going to put them in our code because they are not going to make too much impact when the input is larger. So okay, I ignore the constant values from my complexity. Now again, constant, first thing was to ignore the constant values. Now comparatively small functions or comparatively small values. Now in front of this n cube, this 3n and the n square are the very small values or very small function. Because now let's say somebody is saying, tell me the complexity of this algorithm. Now you will say that my algorithm is doing 3 functions, sir. First one is doing n cube, first one is second is n square, third is 3n. So this n cube will take 1000 second, n2 is taking 100 second, 3n is taking 30 second. So now how much time your complete program is taking? Sir, 1000 second only, because in that 1000 second only it will do its work. It will also do its work. So why to include this in our complexity when this is very small than our natural number that we are getting? So we will ignore the constant values as well as we are going to ignore the comparatively small values. Whatever small values are there, we will ignore them because they are not going to make any effect on us. So technically, the complexity is only n cube here. In this case, the complexity is n cube. Now, this is how we calculate basically. Now, let's try to calculate the time complexity of this code. So, this is just a class structure and this is the main method structure. The executable code is this much only, which will be executed by the compiler. So, in this code, I will ask you one simple question. How many times this line will execute?
Just once.
One time. So we just know that this line will execute only on the one time. Second line will execute how many times? One
One
time.
time.
So the second line is also executing one time. Okay, understood. It is executing one time. How many times this third line will execute? Again, one time only. There is no discussion in this. How many times fourth line will be executing? The fourth line will also execute one time. Now let's combine the complete time. So my complete time is 1 plus 1 plus 1 plus 1. So my function is always working in the constant time 1. And what we are saying, remove the constant, don't include constant in your system. So here I removed all of them. So what is left? Nothing. Of the order of big O of 1. Means let's consider the worst case. In the worst case also, this program will run in the linear time. This program is going to run in the linear time. It is not going to do anything else than this. The complexity of this is of the order of 1. This is one code basically that we are analyzing its complexity. We will write one more code and we will check the time complexity of that particular code. So I will just make the changes in this code only. Let's say int a equals to 3 or let's say 5, and rest one loop is running here. So I will run the loop, and this loop is doing int I equals to 1, I less than equals to 5, I plus plus. And when this loop is running each time, it is increasing the value of a. So basically doing a plus plus. Now, how many times this loop will run? 6
Five
times.
times.
Because 5 time will correct condition, 6th time wrong condition. So
Yeah.
this loop is going to run 6 time. 6 time. How many times this a plus plus is going to execute? 5 time. This is going to execute 5 times. Now we'll do something here. If I'm changing the value of a, then it depends on the value of a. So let's say user will give the value of a. So let's take it from this, the condition of loop. Let's take it from user only. So I'll just do one thing. Now in this loop, let's create the scanner class. So scanner s equals to new scanner system.in. So and int range equals to sc.next int. Simple. And this loop is executing till the number that user will give. Now user can give any number. We don't know what user will give us. So now if I calculate the time complexity of this code, so this object is going to create only one time. So this object is going to create, or this object will run one t time or one time. You can write it anyway. One t means one time or one simple. Int range, you will take input only one time. So this is also going to execute a single time only. Int a equals to 5. This is also going to execute a single time only because it is out of the loop. Now, if I ask you how many times this loop will execute, we don't know. It depends on number of that user is giving input. So let's say user is giving input in the form of n. So like this. So here it will go less than equals to n. So basically this loop is going to execute how many time? N plus 1 time. this loop is going to execute how many time? N plus 1 time. And how many times this a plus plus is going to execute? This a plus plus is going to execute exactly 1 time. Now calculate the total time complexity here. So what is the highest function here? Highest function is n plus 1. So here I will go and write to time complexity. So here time complexity is going to be equal to n plus 1 and 4 time plus 1 plus 1 plus 1 and plus 1. Now let's say user has given n equals to 70. So it will become 71. But all of these are 111 only now. So what is their thing? They are very less than the actual time complexity. So I will ignore them. I will ignore them, ignoring all the constant values. So here I will first ignore the constant values. I'll say, okay, you are not going to be included. Now what I will return? I will remove the comparatively small values. What is comparatively small values? Of the order of n. Let's say the value of n is 70. 70 plus 1, 71. What is the difference? No difference. So remove this also. So finally the time complexity that I'm going to get is of the order of n only, where n is the number of input, how much input user is giving. That's so simple. So like this, I calculated the time complexity of a for loop. So always remember, this is a inbuilt formula or like hard and fast formula. Every loop will have a time complexity of the order of n, of the order of n. So now we are just going to calculate the time complexity of one more code. In the same way, we will be analyzing the time complexity of one more code. Okay, like this only same code is there. And first of all, my outer loop will run. Let me open the Java compiler here. There you will understand better because we can check the live thing. For int I equals to 0, I equals to 1, semicolon, I less than equals to 5, semicolon, I plus plus. And here I will print system dot out dot print ln hello world. Anything you can print here. Now, how many times this loop will run? So this loop will run 5 times currently. Means 6 times it will run, 5 times it will give output. So it depends on the value of n. What I'm writing the value of n. Now, when you have two loops for int j equals to 0 or j equals to 1 semicolon, j less than equals to 2 semicolon, j plus plus, and then we are printing hello world. System dot out dot println hello world like this. Now one loop has been increased inside and it will run 10 times now. 10 times. So basically the first loop was giving output 5 times and this is giving output 2 times. So 5 twos are 10. Means when we are writing one loop inside each other, they are getting multiplied. The time complexity is getting multiplied basically. So in this case, this loop is going to execute how many times? N plus 1 time. N plus 1 time. This loop, whatever is the value of n there. N is just a number of input. Here the second loop is also going to execute how many times? This loop itself will execute how many times?
3 times.
No, it is not going to n plus 1 time. See, this loop is basically executing n plus 1 multiply by n plus 1 time. How many time? N plus 1, then multiply by n plus 1, because 2 time it will execute because of itself, but there is one outer loop who is running this loop 5 times. So this
Yeah.
loop will basically run its value multiply by its parent value. So this is
Got
going
it.
to execute n plus 1, n plus 1, and then n plus 1 means multiplication n plus 1 time. How many times this hello world will execute? Whatever is the n multiply by n. Or
Yeah.
you can write m here, n plus 1, m plus 1. Second loop time is different. Here, what is the running time of this statement? N multiply by m. N multiply by m times. Like this. Now, if you calculate the time complexity of this, it will become something like this. Here, if I calculate the time complexity, then first is n plus 1 multiply by m plus 1, then plus n plus 1, n plus 1, and then n multiply by n multiply by m. Now just try to calculate that how is it working. Time complexity. See, in front of all these values, this n plus 1 is a comparatively very small value. I will
Yeah.
discard it. That I'm not taking you now into my consideration because that is a small value. If you come here, this is nm, n multiply by m. If you calculate this complete structure, let's try to write there a complete bracket. So it will become nm plus n plus m plus 1.
Yeah.
Now take check nm plus n plus m plus 1. What is the, so this number is going to be smaller than this value because in that nm is available except nn, n, m and 1 is available. So here
Yeah.
nm is smaller. So in the next case, I will remove this also. The time complexity will left this one only like this. If you check carefully in front of nm, n is also smaller, m is also smaller, 1 is also smaller. So in the next case, my time complexity will only left of the order of
Mm.
nm. Now here considering n equals to m, then time complexity will become of the order of n square, of the order of n square. So let me write square like typing. So here it will become n square. So we can notice that two for loop inside each other will give us a time complexity of n square. Got it?
Yeah.
Okay. So that is how we actually calculate the time complexity. And our judgment is going to be on the time complexities only. So I will write a code here. You tell me what will be the time complexity of that code. Just a
Yeah.
practice.
Yeah.
Int num equals to 30, int num equals or int n equals to 20. For loop is there. Int I equals to 1 semicolon, I less than equals to 20 semicolon, I plus plus. It will do num plus plus and I minus minus. What will be the time complexity of this code?
Yeah. First line will be one time. Second
Sorry?
line will be like int num will be one time execution, and int n equal to 20 will be one time execution,
Hmm.
and for loop will run for less than 20, so which means 21 times.
Hmm. Or I can write here n plus 1, right?
Yeah.
Then
And then n plus plus and I minus minus will run for 20 times. Means one time.
one time means like n times like that.
Yeah.
So
Yeah.
what will be the final time complexity here?
One n plus one plus n plus n plus one plus
No,
one.
tell me the
So
final answer.
Okay. N.
of the order of n. So
Yeah.
answer is wrong here. Now the reason is very simple.
Mm-hmm.
The reason is you just calculated the loop execution.
Mm-hmm.
You didn't notice a single pattern here that num is
I minus.
getting increased. I minus minus. So this is a infinite loop.
Yeah.
It is a infinite loop. So in case of infinite loop, there is no time complexity. It is a expensive task which is never going to be completed.
Yeah.
JVM's memory will become full and JVM will automatically terminate this program. This is a infinite loop. It is an expensive task. It is not going to have any time complexity as we cannot check its order. That is what the time complexity is. Now let's say what are the asymptotic notation and what is their use case in our time complexity. So here asymptotic notations. Asymptotic notations are the mathematical functions which are used to represent the complexity of any algorithm in the form of an algebraic function. In the algebraic function. So now in this, like previous example, we calculated n square, n, like that we were calculating now. So now
Yeah.
how I can write? Now let's say this was my first case that I was getting. What was my first case? This was only my first case. Now for an example, if I am considering both and n, m equal to each other, then this time complexity will be written in this format. N square plus n plus n plus 1 plus n square plus n plus 1. Now 2n square, because n square plus n square, 2n square, 1 2 3, 3n plus 3n plus 1 1 2,
Yeah.
like this. Now this is my final complexity here. But in this, 2 is a relatively small value. I will ignore it. Constant value, not a small value, constant value. I will ignore
Yeah.
it. Here, this is a comparatively very small value. I will ignore this also. Now, finally, 2 is also a constant value. So I will ignore 2 also. The final complexity that I got is n square.
Okay.
So basically, we can represent the algorithm's time complexity in the form of some mathematical function. There are there are three types of asymptotic functions that we use in our practical programming. Three are there that we use. Here the first one is come as big O notation. Second one is big omega notation. Big omega notation. Then comes big theta notation. Already their symbol I have written in the previous way. Big O. Now, what is big O? Big O represents the big O represents the worst case time complexity. And in interviews, we should focus on this only. Now, what exactly is the worst case time complexity. In this function, so for any, and it represents the upper bound. It represents the upper bound. I will tell what is upper bound also. Now,
Okay.
for any function, let's say you have any function of n, there exists one function such that function of n function of n will be less than or equals to or less than c dot g of n. C dot g of n. There exists another function gn in which your function will be always smaller. So c is going to be the constant value. So finally we can say that our function fn or our algorithm is going to be equal, here g is going to be equal to some c multiply by gn. Now again it's a confusing thing. I'll tell you one part. Let's say you have a function n square plus 3. N square plus 3. Something like this. Or n plus 3, n square plus 3. In any way you can take. Or let's say n square plus 1. Let's say this is your function. This is my function that I am writing. Function of n is equal to n square plus 1. N is the number of input, T is the time. So let's create the graph here. So here I will create the graph. So let's say this is the input number 1. This is the input number 2, input 3, input 4, input 5, input 6, input 7, input 8, input 9, input 10. Here time is going to be 1 second, 2 second, 3 second, 4 second, 5 second, 6 second, 7 and 8. And let's say this is n square plus 3 only. Now you can decide any function, any other function in your brain, any other function that you like. So I will decide that n square plus 3, I am saying that it will be less than n cube. N cube. So now you have two functions. This is your function of n and this is your function of gn, another function. Now put the n equals to 1. When n is equal to 1, so 1 square is 1, 1 plus 3 is 4. So your function will give 1, 4 here. Your function will point here. Now put 1 here. When you put 1 here, 1 cube is 1. So
Yeah.
gn is pointing here. Gn is pointing here. Let's put the value 2. So 2 square plus 2, 4, 4 plus 3, 7. My function is pointing here, but gn will point 2 cube 8 here. So how my function is going? My function is going in this way and my gn is going in this way.
Yeah.
Now after this point, my gn value will always be greater than my fn value.
Yeah.
Now you can put any value of n, the gn will always be greater than the fn. So this is called the situation of big O, that at n2 the gn is greater than function. So here it can be represented as a worst case time complexity of n cube, like this. So we should always take care of the worst case time complexity, that is of the order of big O notation. That's why our complexity is written like this, of the order of n, like this, of the order of n square, of the order of n cube, of the order of n factorial, of the order of 2 to the power n. Like this we represent our time complexity. Now the next one is big omega notation. So big omega or simple omega notation, basically not big. Omega notation represents the best case time complexity. Best case time complexity, and it represents the lower bound. Lower bound. Lower bound means your function value will be is going to be less than the normal that value. Your bound is going to be lower bound. That. So here it represents the lower bound. When it comes to theta notation, theta notation represents the ideal case or the average case time complexity. Average case time complexity. It represents the middle bound. It represents the middle bound. So there will be three functions. Let's say fn is your main function. Fn is your main function, like this. So there exist now two different functions. One is a gn, to which your function is less than, but your function is greater than some other function tn. You will lie between two, best case and the worst case. So you become the average case. That becomes your theta notation, but we don't discuss all of them in interview. If you are able to handle the worst case time complexity, then you are already good. So that's what the asymptotic notation is. They just represent the functions. Now what is the space complexity of any algorithm? So here the space complexity refers to the amount of memory used by the algorithm. How much memory that particular algorithm is using. Space complexity refers to the amount of memory that is used by the algorithm. Now sometime you will get, sometimes we will try to reduce the time complexity from of the order of n square to of the order of n. But in this process, we will increase the space complexity by 3 folds. Means last time if you were using 1 MB, now you are using 3 MB. So this is not an ideal solution. And in this case, the complexity of the order of n square is better than is better than of the order of n. Now let's say I will give you one example. You want to hire a cook and there are two cook who are coming. You ask them that in how much time you can prepare our dinner. The cook one replied, I can cook the dinner in 60 minutes. The cook 2 replied that I can cook the dinner in 30 minutes. Now, in the first fold, you will see that okay, the cook 2 is good. But you ask them what is your demanding salary, how much you demand, what is your expected salary, how much you demand. So, cook 1 replied that I need 5,000. But cook 2 is saying I need 15,000, threefold. So you are not going to think about 30 minutes now. You will see, okay, 10,000 I am saving. So I should go with the cook one. So sometime n square is also better than of the order of n. Just because space I need to save. As space complexity also matters, but not that much it matters, but yes, it matters. Now, one program is
Okay.
taking 10 MB of memory and running in 4 seconds. Now, you want to run it in 1 second, but it will take 400 MB. How come this is good? How come this is good solution? This is not at all a good solution. We should not go with blindly behind the time complexity only. We should always consider how space complexity is working. But generally, we ignore it. In interviews also, we will not be focusing on the space complexity. Our complete discussion will be revolving around the space complexity only and only space complexity, not on the, sorry, on time complexity, not on the space complexity. But why we are not considering space complexity, why we are giving preference to time complexity? Because we are in a high paced world. This world is running very fast nowadays, and everyone has got lot of memory. Now let's say in previous computers around 2000 or 1990s, there used to be a memory of 4 MB only 4 MB memory used to be there in computers. But now in a small chip, we can store 256 GB data, 512 GB data in GBs. So we have lot of space, but time is the problem now. We don't have lot of time. So our consideration always goes around the time complexity only. So that was
Got
the starter towards data structure and algorithms and how we are going to use the concept of time complexity and space complexity. Now you can tell me your doubts if you are having any of them.
I'm clear that, like, uh, just in case if someone wants to know the space complexity of a function, how do we calculate that?
Yeah, how do we calculate the space complexity? So basically, it depends on the time
Mm-hmm.
and what kind of code is written. So let's say I will write a simple code. Int num equals to 30, int num2 equals to 40, double sum equals to num1 plus num2, system dot out dot println sum. How much memory you need for this program? See, memory you need to store the data. Where you are storing the data? In this, I am storing some data. As it is int, and int in Java take 4 byte. So here it is going to take 4 bytes of memory. Second is also int. So here my int is going to take 4 bytes of memory again. 4 bytes of memory again. Now double sum. Double in Java take 8 bytes. Double in Java take 8 bytes of memory. So this third statement is going to take 8 bytes. 8 bytes. Now, is the fourth statement going to take any memory? So answer is it is a print command and printing is done on the console. So it is going to take memory, but not the for storing, just for executing. So it will be taking the unit memory. Unit memory is how much? Nothing. U unit memory. So basically the space complexity of this program is 4 byte plus 4 byte plus 8 bytes. So a total of 16 byte of memory this code will be taking for execution. Now you have written a class will take some memory depending upon the JVM. Main method will take the memory, but we don't care about their time complexity or space complexity. Whatever statement you are executing, we take the complexities of those statements only that we are writing or we are using to store some data. Here,
One more doubt.
yeah, tell me.
So, for example, in sum 1 equal to 30, so we are saying that the storage of the number 30 is 4 bytes, but that int num1 that is pointing somewhere else, right? So that won't like occupy any memory, right?
Yeah, simple, na? That's why I'm writing 4 bytes.
The
See,
variable num1 won't take
no,
any
no, no,
memory.
no, no. I'll tell you one thing.
Okay.
In memory, whenever you are having, so there are cells, right? Our
Yeah.
memory is just a group of multiple billions, trillions of cells
Yeah.
like this. Now, whenever you will write int data type, Java will allot 4 bytes. 1, 2, 3, 4. However, the cells is 1 bit, but I am considering that these are the 4 bytes that Java is giving me.
Yeah.
Like this. Java occupied 4 byte. But who is referencing to these 4 bytes? Num1 is referencing to these 4 bytes.
Yeah.
Num1 is referencing to these 4 bytes. So num1 is basically stored is these 4 byte only. So the entire memory is 4 byte only.
Got it.
Okay, now I will write one code and you tell me the time complexity of that code. Okay.
Yeah.
With space complexity with respect to Java.
Yeah.
So I'll just delete all of this. Tell me the space complexity of this program.
So num1 will be 4 bytes, num2 is 4 bytes. Int equal to 0. Still it's in, so I'm guessing it's going to take 4 bytes. And double will take 8 bytes. And again, int sub will take another 4 bytes. So in total, 16 plus 8, 24.
24. Answer is again wrong. Now Java follows caching.
Mm.
Caching means if
Int C is not used.
here some memory is there, in that you store 30 and num1 started giving reference to it. This memory location, num1 is giving reference to this number,
Mm-hmm.
num1. Num2 is 30. Now Java will check, do I already have 30 number memory? Yes. So now num2 will also reference to the same memory location. It will not create
Okay.
new value. Then you written int c equals to 0. Okay. So int type of data and 0 is the value. Now it is C is giving reference to this one. Now double sum, as you are creating double. So new will be created in which whatever 60 value is stored. Now sum is giving reference to it. You created third variable sub, whose value will come as 0. But
Yeah.
again, 0 is
0
available.
is not okay.
So basically 4 byte here, 4 byte here, and 8 byte here. So a
Got
total
it.
of
16 bytes.
16 byte only it will take again, because rest is caching part. Rest is caching part. It will not
Got
store
it.
multiple times. Okay, now?
Yeah.
Now, why we should believe that Java is doing some caching? Because whenever you are checking something using double equals to sign, this never check the value. It always check the memory reference. So here I will go and type system.out.println. Before this, I will declare two int values. Int num1 equals to 340. Int num2 equals to 340. And I can check them. Num1 is equal to num2. I will run the code and what I will get is true. Now this is
Yeah.
primitive data type. So this is a normal value, but I will change it to the wrapper class. So now this value will become an object.
Yeah.
And object are not cached, means they will be, even if they have same value, they will be stored at different location. If I
Yeah.
run them now, what I will get is false.
False.
Integer caching is not done, but caching is done till 127 only. If the number is 127 in object, then caching is done. Over 127, new object will be created. So this double equals to sign, this never compare the
Value.
values. It always compare the memory reference. If two variables are giving reference to the same memory, they will be done. Otherwise, they will be not done. Got it?
Got it.
Fine, then we'll connect again tomorrow on Monday,
Yeah,
basically.
sorry, lost out. So if we want to compare the value in it, then we only will be using equals, right?
Yes, we will be using dot
Got
equals method then.
got it.
Yeah. Bye bye. Take
Thank
care.
you. Thank you. Bye.